All right, so today we're going to review section 4.6 through 4.8 to get ready for our test. Our first learning target is to solve quadratic equations by square rooting and to also be able to find complex solutions to our quadratic equations. So to solve by using square roots, we want to isolate our x squared term. So for this first one, I'm going to have to add the 81 to the other side. Then I can square root to cancel the square. But remember, you need that plus minus symbol in front of your square root symbol. So we end up with x equaling plus minus 9. On our second one, to isolate the x squared term, we're going to have to subtract the 12 first. So it's going to become negative 12. And then we're going to have to divide out the 3. We want that x squared all by itself. Now, once I have it by itself, I can square root. And remember that when we square root a negative number, it comes out as an imaginary answer. So we end up with plus minus 2i for that one. On our third example, subtracting the 100 to the other side and then dividing out the 5 gives us x squared being negative 20. To square root a negative 20, we have to think of splitting it into a negative 4 and a 5 and square rooting those pieces. So we end up with x equaling plus and minus. The square root of negative 4 is 2i, and 5 is not perfect, so it's going to stay inside. The next learning target we are looking at is to solve equations by completing the square. What we are trying to do is to create what's called a perfect square trinomial. So we are asked what number completes the square. What would make this into a perfect square trinomial? To find that, we take our b term, which is the number in front of x, and divide it by 2, and then we square it. So in this example, my b term is this 12. I'm going to take 12 divided by 2 and then square it. So 12 divided by 2 is 6. 6 squared would be 36. 36 is the number that needs to be there to make that perfect. Go ahead and pause the video and then try this. Check back to see how you did on this one. All right, so what you should have done was taken the negative 8, divided by 2, squared. Negative 8 divided by 2 is negative 4. When we square a negative, remember it comes out as a positive number. So my missing term there should be 16. So we're going to use that process to help us complete the square on this next one. Remember that when you are completing the square, your a value has to be a 1. And in this example, my a is this negative 2. So I have to divide everything by negative 2 first. That turns it into x squared plus 8x minus 11 equals 0. Now I have an equation that I can complete the square on. The 11 is not the number I need there, so I'm going to add it to the other side. And then I'm going to figure out the missing term. What do I need to add to make this perfect? But remember, whatever we add to one side, we have to add to the other. So to find that missing term, remember we take our b value, divide it by 2, and square it. 8 divided by 2 is 4. 4 squared would be 16. So I'm going to have to add 16 to both sides. What I have now is, on the left side, a perfect square trinomial. X squared plus 8x plus 16 will factor into x plus 4 times x plus 4. So we can write that simply as x plus 4 squared. On the right side, we end up with a 27. Now I can square root, remembering our plus minus. The square root of x plus 4 squared is just x plus 4. On the right side here, the square root of 27, we can think of splitting it into 9 and 3. So we end up with a 3 root 3. To solve for x, I simply have to subtract the 4 to the other side. So our answer, my final answer, would be negative 4 plus minus 3 root 3. All right, for question 7, it says write the equation in vertex form by completing the square. Vertex form, remember, looks like this. So we are trying to find something, some way to create this x minus h squared piece similar to what we had right here. Okay, so we're going to use that completing the square process to do that. My first step is to subtract the 3 to the other side so that I can figure out the correct number that needs to be here. And remember, whatever we do to one side, we have to do to the other. So I'm going to find my missing term. I'm going to take my negative 10, divide it by 2, and square it. We've got negative 5 squared, which is 25. So I want to add 25 to both sides. The left side we could simplify down to just y plus 22. The right side is now perfect. It's a perfect square trinomial. Our x squared is going to split into x and x. Our 25 is going to split into negative 5 and negative 5. That will make that negative 10 in the middle if we were to FOIL that out. Now I can simply subtract the 22 back to the other side. And it is now in vertex form. If they asked you to identify the vertex, we would look at this and say it's an x squared graph that has been shifted right 5 and down 22. So my vertex would be 5, negative 22. All right. Our next learning target is to solve quadratic equations using that quadratic formula, and then also to be able to determine the number of solutions by using the discriminant. When we are using the quadratic formula, remember we have to have one side equal to 0. So that's my first step on this one. I'm going to bring everything over to one side. I'm going to subtract that 2 over. Now that I have a 0, I can identify my a, b, and c. A is the number in front of x squared, so it's the 3. B is the number in front of x, so a 4. And c is our constant, a negative 2. And then remember our formula, x equals the opposite of b plus minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so my next step would be just to plug my numbers in. The opposite of 4 would be negative 4, plus and minus the square root. b is 4, it's getting squared. Then we're subtracting 4 times our a, which is 3, times our c, which is negative 2, and dividing the whole thing by 2 times a. All right, simplifying. We've got x equals negative 4 plus minus a whole bunch of stuff in a square root all over 6. So let's figure out that stuff inside our square root. Okay, that's called the discriminant. So we are going to look at 4 squared, which would be 16. We're subtracting 4 times 3 times negative 2. 4 times 3 is 12. 12 times negative 2 is negative 24. So 16 minus negative 24 is really 16 plus 24. So my discriminant comes out to be a 40. Now we do want to simplify this a little bit. So we have negative 4 plus minus all divided by a 6. And in that square root, if you think of square rooting of 40, think of it as 4 times 10. So we would get 2 root 10 if we break that down. And then our last step would be to notice that we could divide a 2 out of all 3 pieces. So if we divide a 2 out of negative 4, we get negative 2. If we divide a 2 out of the 2 root 10, we just get 1 root 10. And if we divide a 2 out of the 6, we get a 3. That would be my final answer. Now sometimes you're not asked to find the solutions, you're just asked how many there are. To do that, we just have to do the discriminant. That's that b squared minus 4ac piece. Okay, so we have a one side equal to 0. A is negative 3, b is negative 2, and c is 1. So b squared would be negative 2 squared minus 4 times our a, which is negative 3, times c, which is 1. Simplifying, negative 2 squared is positive 4. We have a 4 times a negative 3 times a 1, which would be negative 12. So we're subtracting a negative 12, which means we're really adding that 12. So my discriminant comes out to be a 16. Because that is positive, I am going to have two real solutions. Anytime your discriminant is positive, you get two real. On the test, it's not going to ask you for number of solutions and type. It's just going to say number of real solutions. Okay. Our next one, again, b squared minus 4ac. b is negative 7, so we're going to square that. Minus 4 times 13 times 1. Negative 7 squared is 49. We're subtracting 4 times 13, which would be 52. 49 minus 52 is negative 3. So, because it is negative, the number of real solutions would be 0. Anytime our discriminant is negative, we're getting those imaginary answers, so we would have no real solutions. If the discriminant is positive, we said there's two real. If the discriminant is exactly 0, we get one real. And if the discriminant is negative, we get 0 reals. All right, question 11 says, the path of a ball follows this formula. H equals negative 16t squared plus 70t plus 6, where h is the height in feet and t is the time in seconds. So again, picturing that ball, we've got time here and height. And the ball's going to start out at 6 feet, go up in the air, and gravity is going to pull it back. So the first question says, will the ball ever reach a height of 45 feet? Not when, just can it happen? So we are just going to plug 45 in for h. We want our height to be 45 feet. And then we're going to get one side equal to 0, so we're going to subtract the 45 to the other side. And 6 minus 45 would be negative 39. And then we just have to figure out our discriminant. Okay, so b squared minus 4 times a times c. Probably want to grab your calculators for this one. If you take 70 squared minus 4 times negative 16 times negative 39, we end up with 2,404. And since that is positive, our answer here would be yes. We're going to get two solutions, two real solutions. That means it's going to hit 45 on the way up, and it's also going to hit 45 on the way down. So 45 would have to be somewhere in here where it can hit it two different times. Okay? The second part to this question says, when will the ball be at a height of 10 feet? So we are being asked to actually calculate the time. Now we have to go through the whole quadratic formula. This time we want our final height to be 10. So I'm going to put 10 in for h. I'm going to subtract 10 to the other side because I need a 0 on one end if I'm going to do the quadratic formula. And then we're going to plug things into that quadratic equation. So x equals the opposite of b plus minus the square root of b squared minus 4 times a times c. All of it divided by 2 times a. All right, let's clean this up. We've got negative 70 plus minus a whole bunch of stuff in a square root, and denominator would be negative 32. So grabbing calculators, we want to take 70 squared minus 4 times negative 16 times negative 4. We end up with 4,644 as our discriminant. Now, to figure out the times, we actually have to go through this. Sorry, I'm going to change these x's here to t's since we are finding time. It's really the same thing as x. To figure out our times, we're going to actually go ahead and calculate a decimal number for this because we actually want a nice time. We don't want to say it's 5 plus minus the square root of 3 seconds. That wouldn't make sense. So, grabbing your calculators, parentheses, negative 70 plus the square root of 4644, close off the parenthesis, divided by negative 32. If you don't want to use parentheses, you'll have to make sure and hit an equal sign after you put that square root number in before you divide by negative 32. Then you're going to go back and do the same thing, but with the minus sign. All right, when you do that, you should get 0.06 seconds and 4.32 seconds as your answers. So remember, it can hit 10 feet on the way up right after it leaves its starting point, which was at 6 feet, so it's not going to take very long, 0.06 seconds for it to get from 6 feet to that 10 feet mark. Then it's going to go up further, and on its way back down, we'll hit it again at 4.32 seconds. All right, our last learning target is to look at operations with complex numbers. Remember, anytime you square root a negative number, it's going to come out as an imaginary answer. So the square root of 64 would be 8, but the square root of negative 64 would be 8i. If we are adding or subtracting complex numbers, we have to combine like terms. Anytime there's a subtraction sign, I would go ahead and distribute that. So it's a negative 5 and a negative 3i, distributing it to both. Then combining like terms, 4 minus the 5, those are the real parts, would give us negative 1. Combining the imaginary parts, we have 1i minus 3i, so we'd get negative 2i. And remember that complex numbers should be put in standard form, the real number first, the imaginary number second. Here we are adding, so combining like terms, we have a negative 2 and a 6 for the real parts, we'd get a 4. Combining our imaginary parts, we have 11i plus a negative 7i, and so we'd get 4i for the imaginary part to that. Now notice on question 15, we're being asked to multiply. There's no symbol in between those, so we actually have to FOIL this out. 3 times 7 would be 21. 3 times I gets us 3i for outsides. Insides, we would get negative 2 times 7, negative 2i times 7, so negative 14i. And our last term, we have negative 2i times an I, we get negative 2i squared. But remember, our I squareds are negative 1s, so this is really just saying negative 2 times negative 1, which is a positive 2. Now when we go to combine like terms, we have a 21 and a positive 2. So our real part would be 23. Combining imaginary parts, 3 minus 14 would be negative 11 for the imaginary parts. So 23 minus 11i. Our last question is a division of complex numbers. We have 4 divided by 2 plus 5i. To divide complex numbers, we actually have to multiply both the numerator and denominator by the conjugate of the denominator. So if our denominator was 2 plus 5i, we're going to multiply by 2 minus 5i. And then on the top, in our numerator, we just have to distribute. 4 times 2 would be an 8. 4 times negative 5i would be negative 20i. For the denominator, we have to FOIL that out. 2 times 2 would be 4. Insides and outsides, remember, are going to cancel each other out. In one case, we get 10i, in the other, we get negative 10i. So those would add up to 0, so we don't have any imaginary pieces. And then our last term would be 5i times negative 5i, so negative 25i squared. Okay? Once again, I squareds are really negative 1s, so that makes this really a positive 25. So final answer would be 8 minus 20i, all divided by 29.